type communications, or MMTC. And we'll talk briefly about what that use case means. So let's start by discussing the first use case, the enhanced mobile broadband, or eMBB. So remember that mobile data was introduced for the first time in 3G, in the third generation of mobile networking. Prior to 3G, it was only voice and text. Mobile data was introduced for the first time in the third generation. However, the data speeds that were possible in the third generation were very modest, on the order of hundreds of kilobits per second, which, as you know, is not sufficient at all for some of the common applications that we use today on our mobile devices, like video streaming or video calling or video conferencing. It was good enough for browsing. It was good enough for checking emails. And that was a big shift those days in mobile networking, because prior to 3G, accessing the internet on mobile devices was not possible. So it was a big step in 3G, the introduction of mobile data. And in 4G, this was taken to a different level with the mobile broadband use case. 4G was all about enabling mobile broadband like data speeds, tens of Mbps of data speed on our mobile devices over the mobile networks. That was 4G. The mobile broadband capability, which is tens of megabits per second of user speeds on our mobile devices, is good enough for a lot of applications we use today. But for the kind of futuristic applications like augmented reality, like 360 degree ultra high resolution video streaming, 10 Mbps or few tens Mbps is not going to be sufficient. We are going to need 100 Mbps or hundreds of Mbps of speed over our mobile networks. And 5G networks are expected to provide that capability. And that is the enhanced mobile broadband use case or capability. So remember, it is ITU. There is a United Nations agency called ITU, which lays down the requirements for every generation of mobile networking. And the ITU, in their vision or requirements for the fifth generation of mobile networking, laid out this as one of the key requirements that the fifth generation of mobile networks need to support, which is user speeds on the order of 100 or few hundreds of Mbps over mobile network. So that is one of the three capabilities that 5G networks are expected to provide, which were not possible in previous generations. That is the enhanced mobile broadband, or eMBB use case or capability. So that's one of the three use cases. The second use case is ultra reliable low latency communication. So in the next generation, there are a lot of use cases around tactile internet and robotic teleoperation and factory automation. So for example, there is a robo that is moving around in a warehouse or factory, and you need to control that robo from a remote location. So imagine a remote human driver sitting in some back office who has a screen in front of it where it is seeing what the robo is seeing, and it needs to drive the robo. So for this use case to be possible, from the time the remote driver in the back office gives a command, let's say it says accelerate, the command needs to reach the robo very quickly. And the latencies that are needed is on the order of 1 millisecond, right? And that is a capability that is not supported by mobile networks today. 4G networks do not support such low latency communication. However, such low latency communication, millisecond level connectivity latency from some remote location to a robo is needed for enabling use cases around robotic automation or factory automation or teleoperation. And that is the second capability. So again, ITU in its vision document for 5G laid out URLLC, or ultra reliable low latency communication, which is millisecond level latencies over the mobile network, as one of the key capabilities that the fifth generation of mobile networks need to provide. So that's the second capability that 5G networks are going to provide that were not possible in previous generation. The third capability that 5G networks are expected to provide is called MMTC, or massive machine type communications. And the ITU laid down the requirements for this use case with the IoT revolution, the Internet of Things revolution in mind. As you know, we are currently in the midst of an Internet of Things revolution. Internet of Things basically refers to the concept that anything, any object around us could have internet connectivity. So there will be a wireless networking capability in every device, or potentially every single device around us that we would want to access or control via the internet. So not just our mobile phones and tablets and TVs, but also our refrigerators, our washing machines, our dryers, our garage doors, our even the collars that our pets wear, or even the sprinklers in our garden. Everything should have a wireless networking capability and should be able to connect to the internet so that we can access this over the internet and control them over the internet. For example, no matter wherever we are, we should be able to see whether our refrigerator is working fine, or whether our light bulbs are on or off, or if they are on and we forget to turn them off while leaving the house. We should be able to bring up an app and turn our lights in our home off, even if we are somewhere outside. Or same with our sprinklers in our garden, or our garage door, or any object that we might want to control remotely over the internet. So that is the concept of Internet of Things. And for the Internet of Things revolution to take off, one of the key requirements is that the networks, the 5G network in our discussion, needs to be able to support such high connectivity density, because today the 4G mobile networks do not support a very high connectivity density because they were designed to only allow our mobile phones and devices to connect. But suddenly, if we want not just our mobile phones and tablets and TVs, but also every appliance around us or every object around us to connect to the internet, suddenly the mobile networks need to support a very high connectivity density. So this was a new capability that was added in the vision document for 5G. And 5G networks are expected to provide connectivity densities on the order of 1 million devices per square kilometer. Today, the connectivity densities that can be supported is at least a order of magnitude lesser, on the order of maybe 10,000 or 100,000 devices per square kilometer. But 5G is going to take that at least one order of magnitude higher and allow up to 1 million devices per square kilometer to connect to the network. So that was the third use case or capability that was laid out in the vision document for 5G. So just to summarize, ITU in its vision document for 5G laid out three use cases, three capabilities that the fifth generation of mobile networks need to provide, that were of course new and would define the fifth generation, that were not possible in the previous generation. These were the enhanced mobile broadband or EMBB use case, which is all about giving user speeds on the order of 100 or few hundreds Mbps on our mobile devices. The second use case was URLLC or ultra reliable low latency communication, which is all about enabling reliable millisecond level connectivity between the network and our devices, any device that connects to the network. And this is to enable use cases that need such low latencies, tactile internet connectivity, or to enable the factory automation and robotic teleoperation kind of use cases. And the third use case or capability was MMTC or massive machine type communication. This was added to support the IoT revolution, the Internet of Things revolution, so that up to 1 million devices per square kilometer could simultaneously connect to a mobile network. So those are the three key use cases or three new capabilities that would define the fifth generation of networking. And these capabilities, of course, were not possible in previous generation. Now you might ask, where are we in terms of actually seeing mobile networks, that 5G mobile networks that meet these capabilities? So like we had discussed in the previous section, there is a standards body called 3GPP, which is responsible for defining technology standards that could meet these requirements or these use cases that have been laid out by ITU. And based on these technology standards, then different equipment manufacturers and device manufacturers manufacture devices and equipment and infrastructure that conform to this technical standards, to the 3GPP standards, and meet the use cases, support the use cases laid out by ITU. So once the ITU laid out its vision for 5G and laid out the use cases and capabilities that 5G networks need to provide, 3GPP has been working over the last over 4, 5, or even longer to come up with technology standards, defining the standards for a new technology that can meet or support these new use cases. And earlier last year, in 2019, 3GPP laid out, 3GPP published specifications of something known as a non-standalone 5G network. So non-standalone or NSA 5G networks were a step towards the eventual standalone 5G networks, which allowed telecom operators to incrementally add 5G capability to areas of their existing 4G service. And with non-standalone 5G, telecom operators could incrementally add the eMBB capability, the enhanced mobile broadband capability, to their existing areas of 4G service. And if you had a 5G enabled handset, and there are already a few 5G enabled handsets in the market today, if you have a 5G enabled handset, and if your telecom operator has deployed non-standalone 5G, you can get the 100 Mbps or few hundred Mbps of user data speeds over your 5G enabled mobile device. Of course, assuming that in a good coverage area. If you are in a bad coverage area, of course, your bandwidth will be accordingly lower. But if you are in a good service area, if your coverage is good and connectivity is good, you can get 100 Mbps or hundreds of Mbps of broadband speed on your mobile device over the non-standalone 5G network, which would not have been possible over 4G network, because the 4G technology was not capable of providing such high kind of broadband-like speeds. However, non-standalone 5G networks do not support the URLLC and the MMTC use cases. Those will only be supported with standalone 5G networks. And just earlier this year, in mid 2020, 3GPP published the specifications for standalone 5G. And once 3GPP published the specifications, now all the different relevant players in the industry are working hard on manufacturing the infrastructure, equipment, and devices that conform to the standalone 5G standards, so that telecom operators can roll out standalone 5G networks, and we, by having a 5G enabled equipment, a mobile device, can actually benefit from these new capabilities. So pilot deployments have already begun in second half of 2020, and by 2021, in many parts of the world, we are going to see telecom operators rolling out standalone 5G networks, which will support all the three capabilities that we discussed. They will, of course, support the eMBB capability, which is already supported in non-standalone 5G today. But with standalone 5G, they will also be able to support the URLLC, ultra reliable low latency communication use case capability,